Question number 9. We are given the information about a cubic polynomial y is equal to f of x. And 9.1, we are asked to sketch a neat graph of f of x showing all intercepts and turning points. So we get the x-intercepts when f of x is equal to 0. So that would mean the graph is going to cut the x-axis at -1, and it is also going to cut the x-axis at 5, and then when x is 0, f of x is -2, that means this one is the y-intercept. And then the first derivative gives us the turning points. The first derivative when x is -1 is 0, and we have also seen that when x is -1, our f of x or y will be equal to 0. So when this happens, that f of -1 is 0, and the first derivative when x is 1 is equal to 0, that tells us we have a turning point on the x-axis at x equal to -1. So this is a turning point. And then we also have a turning point along the line x is equal to 3. That is, along the line x is equal to 3, we have a turning point somewhere. And they have told us here that when x is 3, f of x is -6. That concludes to say, or that points to say, when x is 3, y is -6 becomes the turning point. So we are having a turning point here at 3, -6. Then if x is less than -1, that is on the left of -1, then the first derivative or the gradient is greater than 0. So we know that for a curve, this is positive gradient, this is negative gradient. So basically what they are trying to say is that we know that this is a turning point. So before -1, we have positive gradient. So we are expecting to have this picture of a graph. And then if x is greater than 3, the gradient is greater than 0. So what we are expecting, greater than 3, if the gradient is going to be positive, we expect the graph to be taking this shape. If it will be less than 0, we'll be expecting the graph to take this shape. So in our case, the gradient is greater than 0, so we are expecting the gradient after the turning point, because when x is 3, we have a turning point. So we are expecting the graph to be going and then cutting the x-axis at 5. So here we have a turning point, and here we have a turning point. So we have our graph like this. So that's how we're supposed to use the information. Remember to put also arrows to show that the graph continues to positive infinity and to negative infinity. 9.2. Use the graph to find the x value of the point of inflection. Now, for the point of inflection, the x value only, we use the x values at the turning points. So, and find the midpoint. So we are saying x value will be equal to, it's negative 1 plus 3, and then we divide by 2, which will give us 2 over 2, which is 1. So the x value at the point of inflection, or the x coordinate, is 1. So if we are to come to the graph, though there are no questions that have been asked pertaining to the y coordinate, we are saying the point of inflection is here. That's where concavity changes. So basically, that's answering 9.2. Then 9.3, for which values of x is the graph decreasing? For which values of x is the graph decreasing? Now, where the graph is decreasing is basically where we do have negative gradient. So this is positive gradient, and then from negative 1 until x equal to 3, what we have is the negative gradient. So the values of x for which the graph is decreasing is from 1 to 3. So we are saying x is greater than negative 1 but less than 3. And that is how you're supposed to answer question number 9.